The Voyager 2 spacecraft has officially bid farewell to our solar system. Launched from Earth in 1977, it has spent nearly 5 decades traveling farther than any other human-made object in history. Then, in late 2021, something curious happened, an event that slipped under the radar for most. Voyager 2, the most distant man-made object in existence, began transmitting usable data back to Earth once again. But according to a few insiders and select AI researchers, this wasn't just routine telemetry. There were no press releases, no media frenzy, only fragments of information, hushed whispers, and obscure online speculation. Even Anderson Cooper, who once reflected on Voyager 2's legacy, couldn't have anticipated this. NASA has reportedly decoded a hidden message embedded in the signal, one with implications that are profoundly unsettling. Voyager 2 launched into the annals of history on August 20, 1977, aboard a Titan IIE Centaur rocket from Cape Canaveral's Launch Complex 41. Its mission was ambitious, to venture farther than anything humanity had ever built. The timing was critical. Once every 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, align in such a way that a spacecraft can use their gravity to slingshot from one to the next in a rare energy-efficient trajectory NASA dubbed the Grand Tour. It was an audacious plan, teetering on the edge of possibility, but it succeeded. By July 1979, Voyager 2 had already reached Jupiter, sending back stunning high-resolution images of the planet's turbulent cloud bands and iconic Great Red Spot. Voyager 2's journey wasn't just a mission, it was a revelation. During its flyby of Jupiter's moon Io, it made a groundbreaking discovery by revealing active volcanoes, making Io the first known geologically active object beyond Earth. This wasn't just a close pass, it fundamentally changed what scientists thought they knew. 2 years later, in August 1981, Voyager 2 reached Saturn. The once assumed simple and uniform rings turned out to be an intricate system, marked by gaps, wave patterns, and embedded moonlets. It also confirmed the presence of a mysterious hexagonal storm at Saturn's North Pole, a phenomenon that still puzzles scientists today. By January 1986, Voyager 2 became the first and only spacecraft to visit Uranus. It captured stunning images of a pale blue gas giant spinning on its side, with a magnetic field wildly tilted from its axis. The probe discovered 10 new moons and a faint ring system invisible from Earth. In August 1989, Voyager 2 once again made history as it flew past Neptune. The deep blue planet stunned researchers with its fierce storms, including the Great Dark Spot, a massive storm nearly the size of Earth. Voyager 2 found 6 new moons and confirmed that Neptune's weather was surprisingly active, despite the planet receiving minimal sunlight. These encounters were far more than just milestones, they marked a profound shift in humanity's understanding of the outer solar system. Voyager 2 captured sights no one had ever seen before. Even now, no other spacecraft has returned to Uranus or Neptune, leaving Voyager 2's legacy unmatched, not just as a tool of science, but as a symbol of discovery. The Voyager 2 spacecraft was not just an instrument, it was a messenger. On board was the Golden Record, an ambitious time capsule created under the direction of astronomer Carl Sagan. This 12-inch gold-plated copper disc carried the sounds of Earth, greetings in 55 languages, selections of classical and world music, and natural sounds like thunder, wind, and animal calls. It also held encoded images of people eating, dancing, studying, and laughing, scenes carefully chosen to reflect the essence of humanity. Etched into the record in Morse code was the Latin phrase per aspera ad astra, meaning, through hardships to the stars. It was a message to whoever, or whatever, might one day discover Voyager 2 drifting through the cosmos, and equally, a message to ourselves. The record was mounted on the outside of the spacecraft alongside a diagram showing Earth's position relative to nearby pulsars, functioning as a kind of cosmic return address. It wasn't designed to initiate contact, but to share a snapshot of who we were at a particular moment in time. In this sense, Voyager became Earth's ambassador to the unknown. For more than 30 years after it passed Neptune's orbit, Voyager 2 continued its silent journey. While most spacecraft end as museum pieces or space debris, Voyager persisted, still listening, still sending faint signals back to Earth. On November 5, 2018, it crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins, becoming only the second spacecraft to do so after its twin, Voyager 1. Unlike a visible planetary orbit, this frontier couldn't be seen. Scientists knew the crossing had occurred when Voyager's instruments began to register a new environment, one that belonged not to our solar system, but to the vast unknown beyond. Voyager 2's instruments registered a sudden drop in solar particles, accompanied by a rise in galactic cosmic rays, a clear sign it had crossed into interstellar space. At that moment, the spacecraft passed into the vast, silent expanse between stars, where radiation, plasma, and particles from distant corners of the galaxy drift endlessly. The transition wasn't dramatic or explosive, it was quiet, cold, and defined by subtle electromagnetic shifts. But it marked a profound milestone. Voyager 2 had officially left the solar system, now over 12 billion miles from Earth. Despite the enormous distance, the spacecraft continues to send back data, though each signal takes more than 18 hours to reach us. Its power source, a radioisotope thermoelectric generator fueled by decaying plutonium, is slowly winding down. Systems are being shut off one by one in a careful effort to keep its final instruments alive. One day, it will fall silent. But for now, Voyager 2 still speaks. Its journey is more than a feat of space exploration, it's a testament to time and human ambition. A man-made probe, racing at 34,000 miles per hour, drifting beyond the reach of the solar wind, still carrying our music, our languages, and our memories. Still active. Still recording. Still transmitting through an unimaginable void. But after decades of steady whispers, something changed. Subtle fluctuations began, anomalies, static, and then, in 2021, a signal that startled NASA's inner circle. It was more than noise. Hidden within the transmission was a message. It would take years to decode, and now, as 2025 arrives, what that message reveals is deeply unsettling. Voyager 2 is now more than 12 billion miles from Earth, over 139 astronomical units, AU, away. To understand that distance, consider that 1 AU is the span between Earth and the Sun. Multiply that by 139, and the sheer scale of this mission begins to emerge. Out there, sunlight barely touches the spacecraft, and radio signals take more than 18 hours to travel one way, 36 hours for a round trip. So how do we stay in touch at all? The answer lies in NASA's Deep Space Network, DSN, a global array of enormous antennas strategically positioned in Goldstone, California, Madrid, Spain, and Canberra, Australia. These locations ensure that as the Earth rotates, at least one station maintains a line of sight with Voyager 2. Each antenna in the network is a colossal, ultra-sensitive receiver capable of detecting signals billions of times weaker than a typical cell phone's. Voyager 2 transmits with just 22 watts, less than the power of a refrigerator light bulb. By the time that signal reaches Earth, it's reduced to a fraction of a femtowatt, yet the DSN can still capture it, lock on, and begin decoding. Thanks to this remarkable system, we've continued receiving data from the spacecraft for decades, magnetic field readings, plasma waves, cosmic rays, and more, all sent from the edge of interstellar space. However, in July 2023, that steady stream was briefly disrupted. During routine maintenance, a command was transmitted to adjust Voyager 2's internal systems. It was a scheduled procedure, handled as usual by the DSN, but this time, something went wrong. It was a routine command, something teams had executed hundreds of times before, but this time, something went wrong. The instruction caused Voyager 2's antenna to shift just 2 degrees off target. That may sound insignificant, but from 12 billion miles away, it was disastrous. Those 2 degrees were enough to break the direct line of communication. The Deep Space Network, DSN, could no longer hear Voyager 2, and telemetry data stopped flowing. NASA engineers quickly realized what had happened. The signal hadn't vanished entirely, instead, it had become part of the cosmic background, a faint whisper buried in the electromagnetic noise of the universe. The DSN could still detect a weak carrier tone, a heartbeat of sorts, but it couldn't decode the information being transmitted. Publicly, NASA acknowledged the problem, confirming that the spacecraft was still alive but no longer speaking in a language we could understand. Internally, engineers set to work on a solution. With Voyager 2 so far from Earth, a direct remote override wasn't possible. The fix had to be simple, methodical, and patient. Fortunately, the spacecraft was pre-programmed with contingency protocols for such scenarios. One of those routines included an automatic reorientation, essentially a scheduled antenna adjustment to realign with Earth. However, that repositioning wasn't due for several months, a delay NASA couldn't afford. Instead, engineers began transmitting shout commands, powerful signals aimed at the spacecraft's last known position, in hopes that Voyager 2 would hear them and respond. In a desperate attempt to regain contact, commands were sent to Voyager 2, urging the spacecraft to turn and re-establish its link with Earth. Yet, there was no way to confirm if those signals had been received or whether the aging probe was still capable of responding. Then, on August 4, 2023, the unexpected occurred, a faint but readable signal reached Earth. Against the odds, Voyager 2 had realigned its antenna. Whether it responded to the ground commands or if its autopilot had activated remains uncertain. What mattered was that contact had been restored, the spacecraft was still alive, still sending its faint whispers from the edge of the solar system. For weeks, the public had feared the worst, with headlines speculating that Voyager 2 had been lost forever. NASA, typically reserved in tone, called it a happy outcome, but for those who had spent decades monitoring the mission, it was more than that. It was a powerful reminder of the fragility of deep space communication, how a single misstep could sever a connection nurtured over decades. Since that event, Voyager 2's signal has remained steady. It continues to transmit science data and basic telemetry, though not without growing challenges. Its systems are aging, and instruments have been shut down one by one to conserve power. The spacecraft's thermoelectric generator, powered by the slow radioactive decay of plutonium-238, weakens each year. By mid-2025, NASA anticipates powering down the last remaining instrument. Still, aside from the 2023 mishap, the data stream has shown no signs of corruption, encryption, or intentional alteration, only the gradual, inevitable fading that time brings. Despite NASA's official stance, some independent analysts have voiced alternate interpretations, claiming they've detected irregularities in Voyager 2's waveform patterns and binary outputs, anomalies they believe suggest a deeper meaning. NASA, however, has dismissed these ideas, labeling them as misinterpretations or the result of statistical noise. According to the agency, Voyager 2 transmits exactly what it's programmed to: voltage readings, radiation levels, cosmic ray counts, pure telemetry data with no artificial intelligence, no encryption, and certainly no hidden messages. It's just physics, resilience, and raw distance at play. And yet, there's a strange gravity in the idea that even these distant, routine transmissions, traveling over 12 billion miles, feel significant. Every packet that arrives on Earth is nothing short of a technical miracle, a reminder of humanity's ability to listen to the farthest echoes of its own creation. Still, not everyone is convinced it's just science. In late 2021, a curious story began circulating quietly through tech communities and private research forums. A small group of insiders, some loosely affiliated with aerospace contractors, others claiming experience in AI, claimed something strange had been detected in Voyager 2's signal. Not noise, and not an error, but a deliberate seeming pattern. These weren't your typical fringe theorists. Many had verifiable professional backgrounds, appearing in closed networks like LinkedIn and GitHub, where they began sharing snippets of binary data, waveform screenshots, and unconfirmed findings. According to them, the 2021 transmission might have carried something more, something that wasn't supposed to be there. According to various accounts, logs allegedly pulled from public Voyager downlinks revealed an unusual anomaly. Machine learning models, originally designed to ensure signal integrity and correct transmission errors, began flagging a specific segment of Voyager 2's telemetry as statistically irregular. It wasn't corrupted or duplicated, just strangely non-random. The flagged data repeated at precise 18-hour intervals, too consistent to be dismissed as mere system noise. Initially, this pattern was thought to be the result of onboard software quirks or redundant checksums. However, as the story unfolded, researchers dug deeper using tools like recursive neural networks and quantum-inspired solvers, algorithms adept at detecting hidden structures in noisy data. What they reportedly uncovered were complex echoes, symmetrical arrangements, and prime number intervals. Among the most sensational claims was the reconstruction of a low-resolution bitmap image from the bitstream, a spiral pattern embedded within a square grid, said to resemble the Fibonacci sequence. The heart of the story was this: at some point in 2021, Voyager 2 had seemingly begun transmitting a secondary layer of data. These patterns didn't match any known telemetry protocols or spacecraft behaviors. They weren't the result of natural interference or signal drift. To the researchers involved, they appeared deliberate. One widely circulated quote came from a now-deleted LinkedIn post by a researcher known only as Marcus D., who wrote, Voyager 2 drifted in silence, until something changed. It began emitting bursts in what appeared to be an irrational prime series, a pattern unlike anything previously seen in a NASA transmission. This led to speculation: was the spacecraft echoing a signal it had received, or had it somehow learned a new form of communication? The claim was extraordinary but never made it into the mainstream. NASA issued no official press release, no journal published the data, no conference mentioned it, and the mission logs showed nothing unusual. When journalists contacted mission control teams in Pasadena and Canberra, the response was uniform: Voyager 2 was operating within expected parameters, its aging systems were naturally degrading, and all transmissions were consistent with established data. NASA held firmly to that line. Yet, the story refused to fade. It circulated quietly, feeding internet theories and creative retellings. The most compelling version featured an animation, the spacecraft floating silently through space, its signal fading into static, then suddenly shifting into a stream of sharp digital pulses. At first, it meant nothing. Then artificial intelligence flagged it, a pattern, a warning. These dramatizations didn't hide their implication. Voyager 2 was transmitting a message. But from whom? Some speculated it wasn't a message from extraterrestrials, but rather a distant signal Voyager 2 had picked up and unintentionally rebroadcast. Others proposed a more terrestrial theory, a rogue code insertion, the possibility that someone had gained remote access to its communication systems. But this, given the nature of deep space communication infrastructure, remains highly improbable. Voyager's aging hardware and narrowband limitations have long sparked debate, but some experts offered a more grounded explanation for recent anomalies, pareidolia, not in the usual sense of seeing faces in clouds or shapes in inkblots, but as a machine's tendency to find patterns in randomness. In this interpretation, what the AI supposedly decoded was nothing more than a statistical coincidence, a cluster of bits that just happened to resemble something familiar. NASA, for its part, has never acknowledged any such decoding in 2021. There are no mission logs, internal memos, or official statements referencing it. According to the agency, Voyager 2 has only ever transmitted the messages it was programmed with back in 1977. Still, for those who believe, whether driven by hope, paranoia, or sheer curiosity, the silence itself has become a kind of signal. The pattern persists, quietly looping through archived data, surfacing in private code, and whispered about in obscure corners of the scientific community. The story gained traction when reports surfaced of a strange anomaly, a 127-bit repeating pattern, not random, not corrupted, but clean, cyclical, and composed of sound wave bursts spaced at intervals just irregular enough to evade traditional error detection protocols. It wasn't detected by human analysts, but by an AI model originally designed to monitor deep space signal degradation. Repurposed to comb through archived transmissions from Voyager 2, the model flagged the pattern while processing a specific segment of data, and with that, a hidden message was allegedly uncovered. According to those reports, what it revealed was far from reassuring. Allegedly recorded in the third quarter of 2021, the signal appeared to lock onto something unusual, a cluster of bits repeating not at standard binary intervals, but according to a hidden sequence of prime numbers, 2, 3, 5, 7, 11, 13. It was a mathematically elegant fingerprint buried in the noise. Then came a second layer of complexity. Within the pattern, another system detected minute fluctuations in bit timing, tiny delays and accelerations which, when charted, revealed oscillations that circled around known physical constants, the speed of light, Planck's constant, the golden ratio. These weren't exact values, but approximations that were eerily close, too precise to dismiss, yet too chaotic to be a standard signal. It felt intentional, though obscured, like a message viewed through fogged glass. The next breakthrough came through spatial interpretation. Using a multidimensional mapping algorithm, one analyst claimed to convert the signal into a 3D projection. The result was a spiral embedded within a cube, a motif strikingly similar to logarithmic spirals found throughout nature, from galaxies to DNA. While some interpreted it as symbolic, others noted its resemblance to the theoretical form of a wave packet in quantum field theory. And finally, buried in what could loosely be called metadata, perhaps a relic of telemetry, were 4 numerical pairs, each tied to an orientation code. They weren't latitude or longitude, but something else entirely, possibly galactic coordinates derived from pulsar timing or cosmic microwave background references. Whatever they were, they didn't align with any known Earth-based system, yet their presence was undeniable. The message appeared to be embedded and repeating, waiting to be read. Its interpretation was anything but ordinary, and for some, it changed everything. NASA insiders noted that, while on the surface it resembled a cosmic greeting, beneath that veneer lay something more troubling, a possible warning. Some experts interpreted the spiral pattern as a symbol of containment, a tightening path spiraling inward. The fluctuating constants were viewed as signs of instability, possibly even a breakdown in the laws of physics. The coordinates embedded in the signal, they argued, might point to a region of space experiencing a mysterious anomaly, or worse, an anomaly moving closer to us. Critics, however, urged caution and proposed more grounded explanations. They pointed to space weather, cosmic rays, charged particles, and electromagnetic storms that regularly bombard Voyager 2. After more than 4 decades in deep space, the spacecraft's aging systems are increasingly susceptible to disruption. A single high-energy particle striking the right memory register can flip a bit, turning a 0 into a 1, and create what appears to be an intentional pattern. This phenomenon, known as bit flipping, is a common issue in long-range communication and is often misinterpreted as structured input, especially by AI systems trained to detect meaning in noise. Additionally, there's the problem of software drift. Voyager 2 runs on code developed in the 1970s, patched and updated countless times over the decades. Its hardware lacks the sophisticated encryption and compression features of modern spacecraft. As a result, even minor instabilities in its systems can manifest in ways that seem structured, particularly to AI models primed to find signals in chaos. False positives are a well-known issue in signal processing, especially when pattern recognition algorithms are allowed to overfit the data they are analyzing. If you make enough noise, eventually something will appear to make sense, especially if it resembles a structure we already recognize. Prime numbers, golden ratios, spirals, these are familiar mathematical forms that algorithms are trained to react to. But familiarity doesn't equal meaning. The mystery may not be the point at all. Voyager 2 has been drifting through the darkness for nearly 50 years, not to deliver warnings or prophesize, but simply to bear witness. It carries no weapons, no instructions, no demands, only a record, a snapshot of who we were when we first dared to look beyond our own world. Born of analog engineering and Cold War ambition, it wasn't meant to endure this long. Yet it continues, sailing through plasma fields, radiation belts, and the vast silence of interstellar space, still transmitting, still holding on to the faint thread that connects it to the planet that launched it. Voyager 2 is a voice in the void. The strange signals, the cryptic patterns, the whispers of something more, they are reflections of our own desire for meaning. We want the universe to respond. We want our machines to discover something greater than silence. So we watch, we listen, we interpret. But whether the signals are merely coincidences or just scientific artifacts, Voyager 2's real message lies elsewhere. It's in the golden record, the image of a mother cradling her child, a dancer caught mid-motion, a diagram of DNA. It's in the music, Bark, Blind Willie Johnson, and in the enduring hope that someone, somewhere, might one day understand. Johnson's words evoke the spirit of the Navajo night chant, an offering, not just a message. Voyager 2 carries greetings in 55 human languages, a chorus of voices saying hello to a cosmos that may never respond. But it's not meant as a warning, it's a testament. What truly matters is that we chose to speak, that we transformed knowledge into action, fear into courage, and science into something beautifully poetic. We dared to imagine that someone, or something, might one day hear us and recognize that we tried to understand. Voyager 2 isn't a scout, it's a time capsule, a drifting archive of a species that once stood on a small planet and asked, "What's out there?" Even after its power fades and its instruments fall silent, it will continue to move, quietly, endlessly, through the stars. It remains untouched by the things that divide us on Earth. What makes it timeless is not its technology or its data, but the intent behind it.